Welcome to yet another video on SRID Cloud. So in this video, we want to talk about a data center network that involves static routing between the core and edge routers inside the data center to an external router. So we will not be using a BGP, at least between the edge and the external routers. We will be using static routing all along. But between the core and edge routers, we will be using BGP. So let's get started. So here is the topology diagram. There is a 172.16.10 network, and it is connected to the core router, which in turn is connected to the edge router through 192.168.10 network. The edge router is then connected to the external router, that is 10.140.10.0 network. And the external network has a tiny network attached to it, 10.1.1.0. The intention is to connect the PC1, which is connected to the 10.1.1 network on the external network, to the PC2, which is connected to the core router and core switch. So now let's quickly look at the configuration of the PC2 to start with. Let me make it a little bit bigger. So the IP address of this particular compute endpoint is 172.16.12, and its gateway is 172.16.11, which is on the core router. And before we go there, let's now look at the configuration inside the switch. So in the switch, a VLAN is already deployed. The PC2 is connected on VLAN 100, and the connectivity from the switch to the core router is a trunk connection. So let's take a look at the configuration here. So the fast Ethernet 00 is connected to the core switch, and that is configured as a trunk port. And the fast Ethernet 01, which is connected to the compute endpoint, is an access port, and it's on VLAN 100. And this is the only configuration that we are interested in the switch. So now let's connect to the core router. Let me make it bigger. So I created a VRF, only one VRF on this router, call it as VRF A, and its route descriptor is 61,000:1. And there is a port channel number 1 with its sub interface, port channel 1.100. It's on VRF A, and it has IP address 192.168.12. So this is the port channel that is connected to the edge router. And there is another port channel number 2, and it has its sub interface 172.16.11 is on the connectivity to the switch actually. And both the port channels are attached to the physical port gigabit Ethernet 1 and 2 using this channel group statement. And there is a BGP definition, and its router ID is 192.168.12. that is IP address on the core router side. And this BGP is between the core and the edge router. And the address family is set on VRF A. The neighborhood is 192.168.11 on the edge router side, and 62,000 is the ASN of the edge router. and 61,000 is the ASN of the core router, and there is nothing else in this router. So now let's take a look at the edge router. So once again, there is a VRF A defined here, and the port channel 1 is defined with its sub interface port channel 1.100. It's on VRF A, and its IP address is 192.168.1.1, and it is also connected to the physical port gigabit Ethernet 1 through this channel group 1. So there is no port channel on the other side of the edge router towards external, because that is intention behind this particular topology. We do not want to use BGP between edge and external routers. And here is the BGP definition for the connectivity to the core router. 62,000 is the ASN of the edge router, and its router ID is 192.168.1.1. And here is address family definition for VRF A. And there is a neighborhood setup towards the core with this statement. The neighbor 192.168.1.2 remote as 61,000. 61,000 is the ASN of the core router. And interestingly, I have added another statement inside this address family setup, that is 10.110 network is also advertised from the edge router to the core router. Later on you will see the need for it actually. This 10.110 is the network attached to the external router. So on the edge router, I am saying I have a route to 10.110 network through external router, and the network 10.110 is advertised to the core router. So this is the essence of this particular presentation, this topology actually. And also I added a route in VRFA for 10.110 network through 10.140.10.1, which we will see in a moment. 10.140.10.1 is the IP address of the connectivity between edge and external routers on the external router side. It's somewhere here. Okay, and there is nothing else. So now let's go to the external router and see how that is configured. There are no VRFs on this router at all. This is purely on a global global routing table. So the configuration on this router is very, very simple. Here is the gigabit Ethernet 1 that is connected to the edge router, and it carries the IP address 10.140.10.1. And the gigabit Ethernet 2 is the connectivity to the other switch, the external switch, and it carries IP address 10.1.1.1. And there are a couple of routes added on this external router. One is to the 172.16 network connected to the core router right at the bottom of this topology, and also I added another route to the 192.168.10 network that is between the core and edge routers. For some reason, if this particular external router wants to communicate to the core router, then this second route will be required. And if any traffic from external route all the way to the 172.16 network right at the bottom of this topology is required, then the first route will be used. So that is it. So these are the various static routes set up on external router as well as the core router. I'm sorry, the external router and the edge routers to accomplish this particular topology. And of course, the configuration on this switch is very simple. There is no VLAN on it at all. Simply fast Ethernet 00 and 01 are turned on, and this VPC has an IP address of 10.112. So let's go to this particular PC1 to start with to validate this topology. It carries the IP address 10.112, and from here I want to ping the 172.16.1.2 IP address all the way at the very end of this topology. 172.16.1.2, and it is working. So now let me do the opposite. Let me go to this PC2. It has IP 172.16.1.2, and let me try to ping 10.1.1.2, and it is working good. So in this video, I'm accomplishing the connectivity between the core and edge router-based network to an external network through external router with the help of static routes. No BGPs, no NATing, nothing. It's purely based on static routes. If some reason, if this particular methodology is desired, then this is how you do it. And I hope you learned how to do the VRFs and BGPs on one end, port channels and so on, and also static routes from one network to the other network across VRFs. And thanks for watching, and have a wonderful day, wonderful evening. I hope you like this video, and I intend to produce a lot more in near future. Have a wonderful evening. Bye for now.